Chapter 17, end of chapters. In question number 6, we discussed earlier, but there is something that we have forgotten to discuss. That is, part A, copy the diagram on your copy, draw and label the forces acting on the aeroplane. So these would be the forces acting on it. Directly downwards, you will have the weight of the plane, mg. And then now, because this is tilted or it is banked, it would have a horizontal and a vertical component, but at 90 degrees to this, that is, this is like this, then acting like this, acting in that direction is why you have L, or the lift. So the lift would have vertical and horizontal components. This would cancel out the mg, and this is the centripetal force needed. So you don't have to draw the green colored ones, but the red colored ones you need to draw. Right, now going to question number 7. Question number 7 is, explain what is meant by the term angular velocity. So angular velocity, you have to have 2 points in here. You have to mention both the points. In the exam, they will give you 2 marks for these if they ask this definition. So that means an object, the angle through which an object moves per unit time, and the angle is measured in radians, right? So those 2 points should be there, right? So both of those points should be there. I'm sure you have given the definition perfectly. Then 7b, figure 17.21 shows a rubber bung of mass 200 grams. On the end of the length of string being swung in a horizontal circle of radius 40 centimeters, the string makes an angle of 56 degrees with the vertical. Calculate the tension in the string, the angular velocity of the bung, the time it takes to make one complete revolution. Once again, this question also refers to the vectors. So you should be able to draw the vector diagrams and figure out the angles and the sine, cos, tan relationships here. So now, when you take this particular event, you can obtain the downward force to be the vertical component to be t cos theta, which will be equal to mg, and from that t cos theta is going to be equal to mg, because that is the vertical component. So you probably must have found out the answer, that is 3.5 n. So from when you do this calculation, t cos theta is going to be equal to mg. So then you substitute the values, equals mg. Then you divide both sides by cos theta. Then you get t equals mg divided by cos theta. mg divided by cos theta. So let's do this and see how our marks are going to be. But the answer, what the answer is going to be, t equals mg divided by cos theta. So now what is m? M is 200 grams, so you take it as 0.2 multiplied by 9.81 g divided by cos theta is cos 56, because the angle is cos 56. If you use the calculator, you will get this to be 3.5 newtons. I'm sure you have got that answer. So now that is the tension in the string. So we have found that. Then part 2, the angular velocity of the bung. The angular velocity of the bung is what they are asking. Now, before we find the angular velocity, we need to find out the centripetal force. So centripetal force in this occasion is the horizontal component, that is going to be T sine theta. T sine theta. So you use the same procedure to find out T sine theta. T sine theta. Now you have found T. You found T to be 3.5 multiplied by sine theta is sine 56. Then you will get the answers to be 2.9 newtons. When you use your calculator, you will get the centripetal force to be 2.9 newtons. But the problem here is they are not asking about the centripetal force, but they are asking about the angular velocity. Now, because they are asking for the angular velocity, you have to use an equation where you have the force, because we know force, they have given it. Force is, we just found force to be 2.9. Then we know the mass is 0.2. What else do we know? Then we know the radius. How much is the radius? It is in a circle of 40 centimeters. So that means it is 0.4. So what is the equation that contains all these stuff along with omega? That is, what is the equation? I'm sure you have taken it. F equals m omega squared r. M omega squared r. So you apply all of these values, you substitute these values, and you will get omega to be 6 rads per second. When you substitute these values, you will get the answer to be 6.02 rad per second. I hope you understood this. Then they are asking for the period. The time it takes to make one complete revolution. So that is the period. So period is, we know the angular velocity. Then we have to find out how long it takes to cover a length of 2 pi. So the period is going to be 2 pi over omega. T is going to be 2 pi over omega. You once again use the values that they have given, and the values that you found out, 1.04 seconds would be the answer. If you have any doubts, please raise questions.